Hi everyone, it's Miss Lauterbach, and I'm going to walk you through your learning today of the slides with our Geology on Mars unit. So today with the slides, we're going to be looking at some new evidence on the channel. So we will begin by reviewing the models and the processes of geologic formation. We'll also do slides 26 through 31. I want to remind you that there's a quiz Thursday and Friday, so you want to make sure you're studying and prep for that. So we will begin by opening up our slides from Google Classroom, okay? And I want to start with slide 21, okay? So we're going to start with slide 21 as a review and then work our way back. So, all right, so when we're looking at slide 21, okay, I want to remind you that this is a model to show water flowing through the earth and how channels form. And one of our questions was, would the channel remain after the water stopped flowing? Which we now know to be true. Yes, the water carved out the channel through the sand, and that channel remained after the water stopped flowing. I also want to remind you that flowing water showed both the flowing water model showed both the hydrosphere, which is the water, and geosphere, which was the sand, both interacting with each other to create the channel. Now, as we hop to slide 25, this here is a model of flowing lava. Now, since we can't use actual lava in the classroom, the model uses wax to represent the lava. So we had similar questions. Would a channel be created from flowing lava, and would it remain once the lava stopped flowing? And we know, based on the footage we watched, that yes, it's true that the lava and the hot wax will create a channel, and it remains after it stops flowing. I also want to remind you that the flowing lava is liquid rock. And so we have liquid rock flowing on top of the earth or sand. So the only sphere that is interacting in the earth model here is the geosphere. Okay. So on slide 26, I wanted you to really compare the flowing water model, image and process, and the flowing lava model, image and process, to our image of the channel on Google Mars. And I really wanted us to kind of look at some, are there any similarities in how it's created? Any indentations that we see that look similar, and kind of get an idea for patterns, okay? So when comparing the channels models to the one on Mars, we need to look very closely at both of the images and make careful observations. I wanted you to go ahead and pick a claim on what geologic process could have formed the channel on Mars and type it into the gray box here. And then I also wanted you to provide your best evidence to why you picked that claim based on the information we have. Right now, the only information we really have in terms of determining what this channel is are the two models and the two images of the geologic processes. That's not quite enough evidence yet to really solidify what created the channel, so we're going to have to do a little bit more digging today. At this part, it kind of concludes the end of our chapter 2 lesson, so we're going to go back to slide 15, and we are going to type in the key concepts. So our chapter 2 question was, how can we gather more evidence about that other planets were once habitable? We hit key concept 3, scientists can use models to test their ideas and get evidence about processes in the natural world that are difficult to observe. We did key concept 4, landforms can provide evidence about the past because they remain after the geologic process that formed them stopped happening. And lastly, key concept 5, models represent the natural processes being investigated in important ways, but they are not exactly the same. So I would pause your video and I would type in these key concepts into Google Slide 15. And then when you are ready, you may resume the video. At this point, we're going to go ahead and start slide 28. So on slide 28, we have some new information regarding the channel on Mars. The NASA has been very nice to share this information with the Universal Space Agency. I'd like to remind you that you work as a planetary geologist for the Universal Space Agency. So this is a good example of how different companies, different corporations work together in the support of science, okay, for new discovery and information. So the NASA team collected information about the elevation of the land where the channel is located on Mars. This image shows the top of the channel is at higher elevation than the bottom, and that the channel is on a steep slope. The bottom of the channel is also more flat. So what this really is telling us is that the channel is going downhill, and as the channel goes downhill, when it reaches the bottom, where it's mostly flat, we get this triangle-shaped landform. That landform is going to be very important as we go out to our investigation. So what we're going to do today is we're going to take a closer look at that channel in the triangle landform. So we're going to examine close-up images of the area near the channel and learn more about what the rover found. The image you're about to see is the same image as the channel we've been looking at, but it's zoomed in on the areas at the base of the channel. We will also get some background information that will help us make comparisons between landforms at the base of the channel on Mars and landforms at the base of the channel on Earth, formed by flowing lava and flowing water. Using this new information given, we'll complete the questions on the next slide. So you're going to open up the data slides here for triangle landforms to complete this slide right here. When I open up the slides, we see here the first information is restating the same material that the Universal Space Agency received info from NASA and that it's real data gathered from Mars. Then we have the same information on slide 2 that the channel is going downhill and it's creating this triangle-shaped landform. Slide 3 is an important slide. Slide 3 reads that NASA scientists found a triangle-shaped landform at the bottom of the channel of Mars. Based on the information gathered from satellites and the Curiosity River, scientists believe that this triangle-shaped landform is made of different types of rocks than the rock around it. So we have different rocks formed inside the triangle than the triangle outside. So that's going to be key information. So we're going to make sure we include that in our channel on Mars here, okay? That the channel is going downhill, and at the base of the hill is a triangle-shaped landform. And we want to add that scientists believe the rocks in this landform, and we probably want to specify that it's a triangle-shaped landform, are different from the rocks surrounding it. Okay. Now we're going to answer questions about the channel on Earth by flowing water and the channel on Earth by flowing lava. So we want to know about the background information of the type of channel, observations we see, and information that's written on the cards. So we're going to start with the background information here on the channel of triangle-shaped landforms on Earth. All right, so this one is formed by water. One of the things I noticed right away is how wide this triangle-shaped landform is, okay? As the water comes out, it creates a very wide fan here, okay? It actually has a name. We call this an alluvial fan, all right? So this is a lot wider. The water creates a wider triangle base than the triangle-shaped landform formed by lava. So those are kind of some key things to note about some observations between the two. Then I'm going to go ahead and read the information about the triangle-shaped land formed by water. So it says that when water flows down a steep slope onto the flat area, the water carries small pieces of rock called sediment. As the water reaches the flat area, it spreads out and deposits the sediment in a triangle-shaped area. Over time, the different pieces of sediment are pressed and cemented together to form solid rock. The triangle-shaped solid rock that forms over time is called an alluvial fan. So one key point in this is not only the shape of the triangle, but that on water-formed channels, we see sedimentary rock that is found at the base of the channel. All right, that's a key information there. So when I look at the lava-formed channel, okay, I notice that the channel looks a little bit longer at the top of the channel, and it collects down at the base of the fan. It's not as wide. And then when I read the information, I'm going to look for anything that would be different from the water channel. So flowing lava can form triangle-shaped landforms at the end of the channel. These landforms are made of rock that forms when lava cools. The rock that makes up these landforms is often black in color because it's made from cool lava. So here, all right, we're going to have rocks that are black, or dark brown, red in color because it's made from lava. All right, lava rock is a different type of rock than sedimentary rock. So here is a really, really key piece of information. Both of these channels have different rocks found at the base. So when I'm going to my notebook slides here, I want to state that the flowing water channel created a wider base for its triangle-shaped landform, but more importantly, that the small rocks at the bottom of the channel are sedimentary rocks. All right, these rocks are a lot different than the rocks found at the channel by lava, because lava rocks are formed by cool lava. All right, which is magma that's reached the surface and cool. So these rocks are black in color, they're a little bit more porous, so they're a lot different than sedimentary rocks. So that's the other key thing here, is that channels created by flowing lava have a smaller base and have lava rocks. So what's really important is if we can determine the two types of rocks found at the base of our channel on Mars, all right, we can really definitively state which of these geologic processes created the channel. If we can find the sedimentary rock, it means the channel was made by flowing water. If we can find lava rock, it means the channel was formed by lava. All right, so once you have slide 30 completed, we're going to move to slide 31. On slide 31 here, and I'll go ahead and delete my little responses earlier, we're going to go ahead and start looking at the evidence we've collected so far. Right now we have about 5 pieces of evidence towards our claims. All right, so our claims are flowing water formed the channel on Mars, or flowing lava formed the channel on Mars. Scientists deepen their understanding of evidence by discussing it together. This is what we'll do today. We will consider which pieces of evidence are more convincing and which are less convincing. So you don't necessarily need to retype the claim because I've already provided it for you, but you will need to click on the evidence link. When you do, it opens up a Google drawing that you'll have to make a copy of each of the evidence cards. All right, so this is the 5 pieces of evidence we've reached so far. You're going to copy and paste the evidence into your Google Slides. Now, this is an evidence gradient, okay? So the first thing you need to do is determine which of these cards is for water and lava. So this one says geologic process by flowing lava. I'm just going to adjust the size here to make it fit a little better. So that's going to go on the right side of my evidence gradient. Now, since these are just images, I'm actually going to put it towards the bottom because that's not very strong evidence. It's just kind of comparison. There's nothing definitively saying this channel is made from lava by just looking at it. Then I'm going to go back and I'm going to pick another card, copy and paste it in. Eventually, I'll do all 5 cards where I'll copy it in to my Google Slides. I'll consider the evidence. So this one's about flowing water. And then since this is a model, I might put it up a little higher because the model kind of shows the same process that's created towards the channel. All right, this is the last stage of your lesson for today. So make sure you have all 5 cards into your Google Slides, and I will see you later on. Make sure you have a good day and email me if you have any questions. Bye.